Alrighty guys, welcome to 6.2. So 6.2 is pretty short. We are doing the exact same thing we did in 6.1. The only difference here is that we are no longer using a standard normal distribution. We're just using the general normal distribution. Okay, so that means that we are going to have different means and different standard deviations. Right? We're not going to have just a mean of 0 or a standard deviation of 1 anymore. But we're still doing the same thing. We're still finding either our areas and probabilities, or we're finding those data values, right? Those z-scores, okay? In this section, we're technically not finding a z-score anymore because we are not using a mean of 0 and a standard deviation of 1. We are now finding those data values, okay? But we're doing it the same way, using our calculator. So to find probabilities and areas, what function do we use? Right, a normal CDF. And to find our z-scores or our data values, what function do we use? Right, our inv-norm. Cool. All right, so let's look at this example problem. So heights of men are normally distributed. Okay, so again, with all of these problems, you want to draw your picture. So we have a normal distribution here. Now our mean is 68.6 and we have a standard deviation of 2.8. All right, so we want the percentage of men who are taller than a shower head at 72 inches. All right, so we're plotting our 72 inches. Okay, and now should I be shading to the right or to the left? To the right, because we want taller than 72. All right, so are we going to use our normal CDF or are we using inv-norm here? Right, we're going to be using our normal CDF because we are trying to find this area, right? When it's using the word percentage here, right, a percentage refers to a probability and our probabilities correspond to our areas. All right, so we're going to use our normal CDF. Okay. Our lower bound is what? 72. And what are we going to use for our upper bound? Right. So a huge positive number, right? And I always use my 10 to the 99. No, that's a terrible 10. Let's try that again. All right. All right, cool. So I want 10 to the 99. And then we have a mean of 68.6 and a standard deviation of 2.8. All right, let's see here. Ooh, I'm gonna try out my calculator. So we would go to second, vars, go down to our normal CDF. Then we want 72, comma, 10 to the 99, comma, 68.6, and 2.8. Wonderful. So we got 0.1123. All right. So whenever doing these, right, I should write my answer here. So we got 0.1123. And technically, we want a percentage here. So I need to change this decimal into a percentage. So I can multiply that by 100, right, or move the decimal place over twice to get that percentage. So don't forget when you get your answer, check and make sure that it actually makes sense. So we wanted the percentage of men who are taller than 72 inches. All right, well, that seems pretty reasonable here, right? 72 inches is essentially, how many feet is 72 inches? All right, so 6 times 12, 72, perfect. So 72 inches is the same thing as 6 feet. So that seems reasonable, right? About 11% of men are taller than 6 feet. Cool. So again, please draw your picture, shade in the corresponding areas, right? Think about whether we want to use our normal CDF or our InvNorm. And then when you get an answer, please make sure it seems reasonable. All right. Cool. Really not so fun to be taller than the shower head. I feel a little bit bad for these 11% here. All right, so just some helpful reminders. I think we probably talked about a handful of these things in 6.1, but it's always good to review here. So please always draw your graph, draw your picture, right? You're either finding that area and probability, and you're going to use your normal CDF, or you're finding either a z-score or a data value, and you're using your InvNorm, okay? So keep those separate from each other. All right, also, we got to pay very close attention to the words that are being used, right? If you're just given 10%, you need to know, is that the top 10%? Is that the bottom 10%? So read very carefully, right? Sometimes the critical reading can be the hardest part of these problems. And then when we talked about z-scores, right? Negative z-scores are on the left, positive z-scores on the right, right? In this section, we're working with data values. So your mean is gonna have units of whatever the data is about, right? If it's inches for height, or maybe it's minutes for time, and just make sure that you're labeling that properly. And then again, our areas or probabilities are always between 0 and 1, right? So when you use your normal CDF, you should always get an answer between 0 and 1, right? Using InvNorm, you should get values that are relevant to the problem. Right? Alrighty, please pause the video here and work on this problem. All right, so we want to find the 95th percentile. Okay, so what is the 95th percentile? What does that mean? Right. So if I'm in the 95th percentile of heights, for instance, that means that I am taller than 95% of women. Okay, so if we are drawing our normal distribution, am I going to be on the right-hand side or the left-hand side? Right. I'm going to be on the right-hand side because I am taller than 95% of people. Okay, so make sure you're drawing your picture. Again, we don't need to worry about our z-score here, but make sure you're drawing your picture, right? We are looking for the data value such that there's an area of 95% to the left. Okay, and again, make sure you're labeling your mean here. So in this problem, it's asking us for the percentile. Sorry, it's giving us the percentile, and it's asking us for a data value, right? We are trying to find that maximum height, okay, maximum allowable height. So when looking for data values, are we using normal CDF or InvNorm? Right, we are using InvNorm. All right, so we use our InvNorm. We have our area to the left, so we're good to go here with our 0.95. We have our mean, 63.7, and hopefully wrote down standard deviation was 2.9. All right, let's get this calculator here. So go in a second. Oh, my calculator is no longer on. All right, so we're gonna go to second and vars. We want our InvNorm. And again, we had that 95% or 0.95 was the area to the left, or the probability, the percentile, a whole bunch of words that I can use. Then our mean is 63.7, standard deviation of 2.9. Great. So we're going to get 68.47. All right, so we have 68.47. So we are no longer dealing with z-scores here. We are dealing with data values. So you need to make sure to have your units here. All right, so what are our units? Right, our units are inches. Okay, so for our problem here, okay, we want to think about if this answer makes sense. Okay, and let's go back to the question so we can look at this. So we were trying to find the 95th percentile of heights of women. Okay, so in the U.S. Air Force, typically they have a very small max allowable height. I believe it's something around 5'2" or so, which is extremely short and limits a lot of women from joining the Air Force. So we were trying to figure out here a larger height that would allow 95% of women to be able to join the Air Force. Okay, so if we have 68 inches, right, that's 5 feet 8 inches. So that would allow a lot more women to satisfy the height requirements for the U.S. Air Force. Okay, so our answer makes sense, right? And also from our picture, okay, we know that we should have something that is larger than 63.7, right? And we got 68.47, so that seems pretty reasonable. Okay, and then we have the second part of the question to answer here, right? This is saying, should there also be a minimum required height, right? What do you think? Well, just imagine if you had somebody who was 3 feet. Would they be able to reach all of the controls, maybe the brake and all of those important things? Probably not. So it would be a good idea for there to be a minimum height requirement as well. All right, so those were our 2 examples from 6.2. Again, in 6.2, we're doing the exact same thing from 6.1. The only thing that is changing is that we are using a normal distribution in general. So we have different means and different standard deviations, but still doing the same thing, using our normal CDF to find areas and probabilities, using our INV-norm to find those specific data values relevant to the problem. Alrighty, well, thank you so much. Please email if you have any questions or join our Zoom office hours. Bye.